What on earth have I created? Welcome to Functionally Imperative, where I build stupid stuff so that you can learn things for the lulz. In this episode, we're going to take something from the internet that's very old and shove it into something that's new in a series that I'm calling CGI-bin for the win. So we're going to take CGI bins and put them into cloud computing in a native runtime. But before we get started, I want to get into a little bit of a history of the CGI bin. So the year's 1993. It's the year that Jurassic Park came out into movie theaters. We had a showdown in Waco, and NAFTA was drafted into law. And at the same time, the folks over at the National Center of Supercomputing Applications, or the NCSA, wrote a spec for what's known as the Common Gateway Interface. So a little backstory, just 3 years prior, in the year 1990, Tim Berners-Lee and the folks over at CERN made HTTPD. This is how HTTP was hosted on the internet. And a request would come in and you would have your files that were hosted, like your index.html and your, catpics.gif. And as soon as people started doing this, we realized we wanted to interact with other backend systems in what we would call gateways. And everyone was sort of creating their own method for this. And it wasn't until the draft for the Common Gateway Interface was created that we started having a common pattern for doing this. And if you look at the context, CERN creates HTTPD in 1990. CGI was proposed in 1993. W3C, the governance body, was created in 1994. JavaScript didn't come out till 1995. And RFC 3875, which was the formalization of the CGI, didn't come out until 2004. So if you look, CGI predates even JavaScript, which has gone through many iterations in the modern world. So before we really get into making our own CGI script, we should talk about how CGI scripts work in the first place. In the Unix operating system, we'd have some command line program. And typically what you do is you would pass in some data. We call this standard in. And then it would go out into standard out. And the sort of Unix philosophy is we would string these things together. And this is how we wrote programs. We also might want to pass in some environmental variables that would kind of just give us extra context in what we were going to be running. And then sometimes mistakes happen. And of course, that needs to go out to what's called standard error. If we overlay this on top of the way that the HTTP standard was, we have a URL with some file names and some query parameters. And we might even take it in multi-part form. This would be, maybe your email newsletter sign up. And maybe we'd want to post that to this URL. So let's map all of this to a Unix command line tool. The LLL.CGI is going to be your program. Your multi-part form is going to go into standard in. Environment variables would give us all the context of the stuff, maybe like information about the URL, query string parameters. And then we spit that out into the standard output or standard error, depending on what's going on. This, in a nutshell, is the thought behind how CGI scripts work. So you would take your scripts and you throw them into a folder called /CGI-bin. And if you're on a Windows machine, CGI-bin is where you would put your PowerPoint.dil files and your Zune files. It's very important for Windows users. In a nutshell, I think one of the best ways that we can show you how this works is to actually have a really simple Python script. To make a CGI script work, all you need is the first line be the content type, and then the rest of the information that you're going to render for the output just shows up in the web page. It sounds too good to be true, but it actually freaking works. If we go over here and look at this, we have this hello world. And let's see, if I pass in a query parameter of foo equals bar, it shows up right here in the query strings. Very, very simple. If I curl to the URL, it loads just as you would imagine. All of this is just the basic HTML that we had built in as well. I can also pass in environment variables. In this case, I say env equals false. This is special instructions I want to send to my script. And then I also want to print out CGI bin for the win, cool, lulz. And in this case, we can see that the environment variables are no longer listed, and bam, there's our stuff in standard in. So with these basic building blocks, we can start building out our amazing CGI script. What are we building today? Well, we're going to be building a CGI script, and we're going to also have a dev runtime. Before we get started on the build, first we need to have a conversation about the research and the design constraints. that we'll impose on ourselves for this build today. When it comes to design constraints, first, no JavaScript. CGI-bin came out before JavaScript, so I thought it would be fun to make sure that this does not have any JavaScript on the site. It also needs to have a period-appropriate UI, meaning when we do our research spike, we need to see what was available at the time and what things we could take advantage of. Another constraint is that it's a single binary CGI bin. This means that the entire CGI script is a single executable file, but this also means that all assets will be embedded inside of the single executable. That means image files, HTML, everything involved in the project will be in a single executable. For me, this means that it will be written in Go, because that's a language I feel productive in, which also means that this project will never quite be good enough for a dedicated Rust developer. Now let's talk about research. In my research on the topic, I found a pretty fun list of features that were common on old websites. I looked for examples that were period appropriate. Some of these sites are tragically okay. And I also dug under the hood to see how some of this was built, which is amazing. And there's a project I discovered that's part of the Internet Archive that is just absolutely, well, you have to see it yourself. It's everything you'd ever want if you needed to get assets for a 90s website. So here's the findings from my research. This site will include an ample amount of GIFs. It's going to be built in a table-based layout. It's going to have a counter to keep track of all of the visitors for this site, and it will have an animated background that will be swappable. And I've created a mock-up for what the site will end up looking like. It will have prominent GIF animations featured on the site. We'll have a counter in the middle. I want it to be an atomic counter that's also serverless, that's actually going to be built into DynamoDB. I think that'll be brought up in the next episode. It's table-based. It meets all the design criteria and all the design constraints. And so let's get right into it. Let's over-engineer a ridiculous website, a ridiculous CGI website from this. So as you can see, I've written a bunch of code. We've gathered some assets. These are the ones that I ended up picking. We've got beautiful alien, spinning diskette, fireworks background, peace sign, dancing Spider-Man and the gang. We found this beautiful, beautiful starry background and a yin-yang. I've also templated out the entire website, and we are going to be using a feature of Go, which is called embed, which is actually a pretty new feature of Go. We're actually embedding all of the assets into a single binary. So that means that everything, images, the HTML template, everything lives inside of a single file. We also have a few things that we can interact with. That means that we'll be able to toggle the background, super important feature. We can randomize the images. So if you pass in this random parameter, instead of the images that I picked, it's going to just randomly pick them and put them in the sort order. I've also, I've abstracted out the counter. So we've got a in-memory implementation of the counter. We've got a temp file-based version of the counter. And I have a DynamoDB version. DynamoDB is a serverless database that is on Amazon Web Services. If we want this thing to scale, ultimately, we absolutely want to have DynamoDB. And then we have our basic counter implementation right here. So we put all that together. We run our website, and boom, the ultimate counter. This is going to be a beautiful website to be running on our serverless cloud infrastructure. The ultimate goal, of course, is to make, now that we've created this, we'll be rolling this out into a serverless custom runtime for CGI bins, and that's what we're going to be focusing in the next episode. So let's look at some of the features. So in this case, we can pass in a query string parameter. So let's say we want to say random equals true. Super important. Bam. We're hosting our beautiful CGI website where now we can randomly pick the pictures. And let's say we're getting tired of the beautiful starry background. We can swap this out and go into BG equals fireworks. Very important. Bam. Okay, so now we're generating random images per request, and we've got fireworks in the background as our counter continues to go forward. So every time we reload the page, the counter increments up 1. And bam, 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 bam. Easy, easy, easy. So what's next? We'll be building a custom runtime for CGI on AWS Lambda. Plus API Gateway and DynamoDB implementations. Thanks for watching. If you enjoyed this episode, please like and subscribe. Links to the project files and other random stuff are in the description. And don't forget, life is better when you learn things for the lulz.